paid for 50,000 for your new patio. So that's how much concrete you've got. Which of the following would be the best estimation for the dimensions? So which of these has dimensions that's really close to 50,000 cubic inches? That's what the question's asking. So to figure that out, we need the length, width, and height all in inches. Currently, there's a bunch of them that are in feet. So to convert from feet to inches, you multiply by 12. And that will be inches, because there are 12 inches in every 1 foot. So we've got 15 times 12 is 180 inches. By 180 inches, by 1/4 of a foot is 3 inches. You can do 1/4 times 12 if you want. So converting that all to inches, that is 180 by 180 by 3, all in inches. And 180 times 180 times 3 for the prism is 97,200. That is not approximately 50,000. So no, not A. Six times 12, 72. 12 and 1/3 is times 12 is 148 inches. And then 6 inches. So multiply that all out. 72 times 148 times 6 inches is 63,936. That is also not very close to 50,000. 6.1 feet, so 6.1 times 12 is 73.2 inches. 10 and 1/3 times 12, so 10 point, a lot of times 12 is 124. Then by 5.5 inches, multiply that out, 73.2 times 124 times 5.5 is 49,922.4. That's pretty close. And then the other one, if you multiply that out, it does not come nearly as close. You get 98.4 inches by 117.6 inches by 6 inches. You get 69,431.04. So C is definitely the closest answer. Makes most sense. That's what you pick. So what three-dimensional object do you get when you rotate a rectangle when the axis of rotation is on one side? So if we've got a rectangle and the axis of rotation is along the side, that's going to get you a cylinder. If you've got a rectangle, or not a rectangle, a right triangle, and the axis of rotation is one of the legs, I'll be like right there. That will give you a cone. If you have a semicircle and you rotate around the diameter, that is not a very good semicircle. You rotate around the diameter right there, that will get you a sphere. If you have a rectangle and the axis of rotation is down the center, so here's a rectangle, and you go down the center, so that it bisects the rectangle, that will be a cylinder. Go down the center of an isosceles triangle. That's going to make a cone. And if you've got a rectangle and the axis of rotation is perpendicular, so if you go perpendicular to one of the sides here, you're going through it like that. Or the other way, it wouldn't really matter. Either way, you get a cylinder. New Hampshire wants to vote in the next election on a new land tax. The government's proposing $10,000 per 500 square miles. How much revenue would the state collect? So, figure out how many, approximate the square miles, the area of the state of New Hampshire. So I would take the average of these two sides. But it's average, so we divide by 2, so you get 49.5. And then do the same thing for the other two sides that are across from each other. 193 and 189. That's going to average out to be 190.5. So that makes this more like a rectangle. You can estimate the area now just as a rectangle by multiplying 49.5 times 190.5. So we have the area is about 9429.75 square miles. And if every square mile, they're saying $10,000 per square mile, per 500 square miles. So how many 500 square miles are there? So we're going to divide by 500 to figure that out. It's 18.86. We'll just round up to 19. And it says that that's times $10,000. It'd be $190,000. So to try to find the density in grams per cubic centimeter, we know that the cube has 3-inch sides. So we're going to take those 3-inch sides and find the volume of the cube. So if it's a cube, it's 3 by 3 by 3. The volume is, formula is S cubed. We just do 3 times 3 times 3. 27 cubic inches. We need to convert that using the fact that 1 cubic inch is approximately 16.4 cubic centimeters. So to do the conversion, we've got cubic inches on top, so we put the 1 cubic inch on the bottom so that they cancel each other out. And then the 16.4 cubic centimeters up top. .8 cubic centimeters. And it wants to know the density when you're solving for density. It's going to be mass divided by volume. Here's the volume. Density equals mass divided by volume. So we're going to take the mass, 785, divided by the volume, 442.8. About 1.8 grams per cubic centimeter. Find the volume of each of the following solids with square bases. So this has got a 30 by 30 square base. This also has a 30 by 30 square base. This has a 22.5 height. This also has a 22.5 height. So we've got a prism and a pyramid with the same base and the same height. The only difference between the two then is going to be, this is area of the base times height. This is 1/3 area of the base times height. Times 30 for the base is 900 times the height, 22.5. Do the exact same thing for the pyramid, but it'll be 900 times 22.5, and then divide by 3. So the prism is 20,250, and the pyramid is 6,750. How do the volumes compare? Well, we could have answered that before we did anything, actually, because the only difference is the 1/3. So the difference is the pyramid is 1/3 of the prism. So we are looking at Yuma County. Population density, we know the population density. We want to know or estimate the actual population of the county by first estimating the area of the county. So if you're going to estimate this, we've got this side's 80, this side diagonal is 100. Going to here is 68. We actually don't know that side. Drawing it out though, I think it looks pretty close to 80. It's close enough, I think, that we can estimate it. It looks like it's about the same. When I drew it, it felt like it took about the same amount of time. We'll say 80 over there too, just to make it easy. So 100 miles, 68 miles, we are going to average those two. So average those two sides, you get about 84. And if we're using 80 for the height, multiply 84 times 80. $6,720 square miles. And then we're talking about density, population density in particular. So population, area, and density makes that little triangle, PAD. And we want to estimate the population. So we're looking at the top, which means we're going to multiply density times area. We're going to multiply the density times the area. The density is 34.47. The area is 6,720. So it's 231,638.4. I would round it up to 639 people. Explain Cavaliers Principle and provide an example. So Cavaliers Principle states that if All the cross-section areas are the same. Same cross-section area. And the same height. They have the same cross-section areas and the same height. They have the same area. Or same volume, sorry, wrong word. They have the same cross-sectional areas and the same height, then they have the same volume for any 3D objects. All the cross-sections are the same and the height's the same, they've got the same volume. So the example we talked about in class, when we passed out textbooks, I had a stack of textbooks that was all stacked up nice and neat, and another stack that was all messed up and weird. Didn't matter if they had the same height, the books were stacked the same height, and all the books were the same in between, they had the same volume. So find the volume and surface area. So let's do volume first. Since this is a prism, we need the area of the base times the height. So the area of the base is 4 times 6, that's 24. Times the height is 8. (192 inches cubed). That's the volume. For the surface area, we're going to start by finding the lateral area. And then you get the lateral area, you do perimeter times height. So we need the perimeter, 4 plus 6 plus 4 plus 6. So the perimeter is 20 times the height is 8. Now to get the surface area, it's the lateral area plus the two bases. 160 plus the two bases. We already found the area of the base was 24. We did that on our volume. So we've got 2 times 24. Add that up, you get 208 square inches. So for a pyramid, it's almost the same calculations, except volume is 1/3 area of the base times height. So area of the base, these are all 30, so we do 30 times 30 for the area of the base, that's 900. Times the height is 8. The volume then is 2,400. So the volume is 2,400 cubic inches. Surface area, you do almost the same calculation, except lateral area this time is 1/2 the perimeter times the height. So we do 1/2 the perimeter is 30, 30, 30, and 30. And we need the slant height, which actually is not given to us, so we can't actually do this here. So we don't know the slant height, so we can't actually finish it off with surface area.